Hi, I'm Andy Kane, and I'm going to overview the MTS Axial 809 Axial Torsion machine that we will be using for the torsion lab. Quick overview of all the equipment that we will be using. This is the machine itself, our top and bottom grips. This will be our axial torsional extensometer, and this is a hydraulic pump unit that drives the, movement of this machine. And then lastly, we have our software that controls it. Now that the machine is running and you have a good overview of how that works, let's look at the software. In the multi-purpose Elite software, we have it opened up. First thing we're going to need to do is open the test for our specific sample. We have two samples. We have the open thin wall, which is this with a slot cut through it, and then we have the closed thin wall, which is essentially the same thing, but there's no slot. Both of those tests are different because the open thin wall with the slot cannot handle near as much force or torque, so it's important for you to open the right test. So first thing we're going to do is open the test. We'll go desktop, and we'll go ASIN 3112, Lab 1 Torsion, and then pick your test here depending on which sample you're using. We can start with the 20-inch pound in return, which is for the slotted sample. As you can see, the 400-inch pound in return is for the closed sample. As you can see, there's much larger difference in the torque applied. Alright, the first thing you're going to want to do when you open this is go to New Test Run. So now we'll restart. You want to click OK. OK a second time. And you will be prompted this window. 20-inch pound in return. This is for the open thin wall specimen, slotted tube. Make sure that is right. If that's not right, you can break the sample unintentionally and damage the extensometer. So make sure you do that. So first thing you're going to want to do is click Run to start the procedure, and then Run. Now it'll allow us to. I prefer to perform the task and then close. But now you are given these prompts up top. And so the first thing you're going to want to do is confirm that the test section is empty. This is important to make sure that the test section is actually empty, because if you go throughout the steps without confirming these, install the specimen, there's nothing that's going to stop you from installing the specimen, but make sure that you actually confirm these, because if you don't, the machine's going to actuate, and if the specimen is installed, then you will damage, you'll break the sample most likely. So I'm going to confirm it. It's going to move to its initial position and give me the first dialog box for how to install the specimen. Follow these directions directly to install the specimen. For the specimen installation, I have grabbed the correct specimen. For our case, we're using the slotted tube. As you can see, there's clearly a slot down the specimen. The first thing we're going to have to do is unlock the interlock so that we can control the crosshead in a position that this can fit. As you can see, it's way too low. So we unlock the crosshead and we move the crosshead up. Now that there is enough room for me to come down and put it in here, we are ready to close the bottom grip. Install it and then close the bottom grip. We have Sharpie. It's probably hard to tell because it's fairly warm, but there's a Sharpie line that tells us how far we need to insert the specimen. Things to note is that this part of the grip will lower down, and the grip teeth itself will stay at the same height. So as long as you line it up and then hold it steady, it will align itself properly. So now we're going to close the bottom grip, and it's really important for you to have a couple things. Have your safety goggles on. You're going to want to have those on at all times. And then also be aware of any fingers in the way. You do not want to pinch yourself because of the hydraulics. Does not care what's in the way. It's going to close the grips. So you're in a good position. You want the slot facing out. That way our extensometer can sit right and then close the bottom grip. Now the bottom grip is installed. The next step we want to do is always want to follow your instructions. You don't need to see it directly, but actually now we're going to have to zero our signal. So if you want to pan over here, we want to zero the signal of torsional torque and axial force, which are these here. So all you do is right click and zero signal. And then the same thing for torsional torque. Right click, zero signal. Now we're ready for the top grip portion. Back at the machine, we are prepared to lower the crosshead. It's important for you to check the alignment of the specimen with the top grip, because as this comes down, you want to make sure that the circular teeth come down over top of it. Also make sure that your top grip is open, because there's no way it would just come down and crush the specimen. So I will start bringing down the crosshead, checking the alignment. The alignment is fine. Get it roughly to the black line. And now we're ready to close the top grip. Close the top grip. And now the, and last thing you're going to want to do is lock the interlock, because we're no longer going to be moving the crosshead. So that is the installation of the specimen. So now that we have done everything, one thing you might want to do is measure the specimen length. That is the test section length, so you want to go from the top of the grip to the bottom, as far as the actual test section goes. And now we are good, so we can close this, and then, like I said before, always confirm within the software. So confirm specimen installation, check. Now we are on the extensometer installation procedure. One thing to note is this extensometer is roughly $6,500. It is not cheap for a very small thing. It's a small sensor that is very sensitive. So use extreme caution, and don't do anything crazy with it. Here is our axial torsional extensometer. The first thing you're going to want to do is always handle it via grip points. We have 5 grip points. We've got these 2 here, this center one, and then 2 here. Really, I just kind of use these 2 in the center one. You'll want to look at this little outer shell. If it has this outer kind of protective shell, then that is a good grip point. A 0 pin had just fallen out, but it is important for these to stay in. Essentially, the 0 pins are there to tell the sensor or hold the sensor in place at the position of 0 deflection. And so the first pin is going to have to be removed. This is our center 0 pin. I'd recommend having 2 people, have one person flexing it slightly while the other person twists and pulls to remove it. Now that the 0 pin is out, we are prepared to install it on the specimen. This again is a 2-person job, so I will have Will come around and hold the guiding spacer. One thing to note is on this back side you can see this little corner. We've designed this spacer to have a notch out, and so you'll want to use that to align it. What this does is this centers the extensometer right on the center portion of the specimen. You're going to want to be right at the center because that's it's really important to avoid any kind of slipping for the extensometer. Now that the extensometer is installed, you'll want to look at it and make sure that it is lined up with the specimen. We've done this many times, so it's really easy for us to do that, but this is something that you might have to do a couple times to get the feel for it. Now that this is installed, we need to go back to the software and zero the extensometer signal. This is the same as the torsional torque and axial force. I don't need to show you, we're going to have to do this twice, so I'll show you the second time we do it. Now that I've zeroed the signal on the screen, I can see that the signal is 0. Now that it's 0, I need to begin removing these 0 pins. The reason why we zero it the first time is to give us an initial state knowing that it's 0, and we have a threshold of 0.5 degrees of deflection. And so as you do this, you want to be really careful. I like to alternate sides because all that matters is at the end you're not above the 0.5 threshold. If at one point throughout the removal of the 0 pins you go above 0.5, that's fine, but once all the pins are removed, it needs to be below that threshold. Saw some movement, but hopefully that wasn't too bad. Now that all the 0 pins have been removed, we will, the extensometer is ready for testing, but we will have to confirm, and I can see on the screen that I'm at 0.13 degree deflection, which will move the camera over. But one last thing to note is this is ready to go as long as we have not passed the threshold. So we're going to go back to the computer and see that the extensometer is below our threshold, so we're going to now zero the signal by right-clicking and clicking zero signal. And now we're at 0. One last thing back over at the machine was to check these wires to make sure that they are not in the way. We have them hanging up in the back. Make sure there's enough slack in the wires such that when the machine starts to move, they're not going to get caught on anything and rip the extensometer off. Then also take your foam and set it somewhere else. I will set it over here on top of our hydraulic pump unit. Now the extensometer is ready to go, and we will move on to the next step in the process. Now that the extensometer has been installed, we will close this window and then confirm it on our operation buttons. Confirm, and now we need to install the protective enclosure. So after looking at these steps, the first thing we need to do is take our protective enclosure, which is this right here, and then set it up on top. It's really important that you watch those wires and make sure you don't pinch anything. I'm going to slide this back. I'm going to slide it back far enough that the back wooden plates are over it, but not too far back that this front plexiglass face does not come into contact with the grips. On the side we have our grips, and we'll use that to clip in the protective enclosure. When you're doing this, make sure that you're not grabbing anything on the bottom of the machine, and you're hooking to just this metal piece right here, because you don't want to cut off any valves or anything. And also watch your feet as you're coming through. Now that our protective enclosure is installed, we've created a safer test environment. Just in case anything does go wrong, you don't have to worry about anything flying out and hitting you. Same thing with the safety glasses. Always want to be safe, especially with the machine of this power. So now that this has been installed, we will check that we have confirmed all of these. We'll close the window and then confirm protective enclosure installation. Now, this box pops up. This is an important box because during the installation process, we unlocked and locked the interlock, which has an effect on the computer. So what we need to do is we need to go up here and then click this Reset Controller and Program Interlocks button. We click this, and that resets it, and then we can click Run again. Now we are ready to start the test, and we click Start Test. As the test moves, you will notice that our plot for both the torsional torque and torsional angle. Torsional torque is on the y-axis of both of these plots. This is our torsional angle, which is the angle of the machine grips itself. And then this torsional epsilon, this is our extensometer's data. They will look similar, but it's very important. They will be different, and you'll be able to recognize that difference within analyzing the data. This is going to give you the much more accurate results. Throughout the test, you will watch it linearly increase. I will make note that the standard stress and strain curve, which this is somewhat mimicking, is linear in the opposite direction. The reason why it's like this is because of the way we've plotted it and the way the software doesn't allow us to create variables to go negative. We're rotating in the negative direction, which causes it to go the opposite way, which is kind of annoying, but it is still linear, and you can watch as the data comes in throughout the test. For this test, we are going to be going to 20 inch-pounds and then returning. We're at about 13 right now, and it's going to work its way up to 20 and then step back down to 20. This data is looking a little bit jumpy, but we'll kind of want to look at the data at the end of the set and judge it towards the end. And if it jumps too much, if the teeth on the extensometer slip, then we might want to retest, depending on how much the data is affected. Now that we're at the end of the test, we've kind of brought the recording back. You can see this data is really jumpy. That's a pretty messy looking data set. So if we were to be analyzing this set, we would probably retest. But for demonstration purposes, we've done a good job of explaining how to install everything throughout this process. The test takes about 7 to 10 minutes, depending on the sample, so we didn't need to show the whole process. But now that we're roughly back to zero, the machine's going to do a little working back and forth until this is zero, and then pop up with test complete. Now that it's complete, we will confirm it, close it, and then confirm test complete. Once we do that, we will get another dialog box, and essentially we're going to step backwards from the installation process to now the removal process. And so on the machine, now we need to remove the protective enclosure, which is the same thing. We take our clamps, we remove them, we install the clamps back on the side of the machine, and then set the protective enclosure down somewhere where it's not in the way, with just a few people in here right in front of the room, but when you have more people testing, we'll probably set that aside somewhere else. Now that the the removal of the protective enclosure is done, we close and confirm, and now we do the extensometer removal. This again, expensive, be very careful. We get our 0 pins back. All the 0 pins are the same, so you don't have to worry about knowing which one's which. You want to install the 4 0 pins on the sides first. And when you're doing this, make sure you're not forcing anything. There's no reason for any of these 0 pins not to go in fairly easily. So if you're having an issue with that, talk with the LA and they will get you figured out. Right in there, I can't see it. There we go. Now that all the 0 pins have been installed, you want to flex the extensometer to remove it. Now you want to reinstall the final 0 pin, which is kind of tricky, but I might be able, I can do this with one person, but I would recommend having somebody else pushing it while another person flexes it. Now that all the 0 pins have been installed, you want to set the extensometer back on the foam pad, and we like to set it on the foam on the side such that if we lose power and this drops down, it's not going to come down on the extensometer. Set it closer to the support column rather than the actuating grips. Now that our extensometer has been removed, we can return to the software and close and confirm. And now we need to remove the specimen. First thing we're going to need to do is unlock the interlock and then open the top grip. When you're doing this, you might hear a little click. The specimen itself gets seated pretty deep or pretty solid onto the teeth, and so it doesn't always come out right away. I didn't hear a click, which means that it's still on there pretty well. And so what we do is we take this mallet and lightly tap. You don't need to hit it very hard, just lightly tap it and make sure that it has been removed. And that's important because the next step is to raise the raise the crosshead, and if it's stuck, then it will grab these teeth and then pull them down, which is really bad for the machine. So we'll watch out for that, and I'll make sure as I'm doing it to release if it does. But we've got the removal, no stuck grips, so we're in a good position. Next we need to open the bottom grip. This is much easier just to move out and then take the specimen out. So that is your full test procedure. I guess the last thing you're going to need to do is come back over here and close and confirm specimen removal, which completes the test. The last thing you're going to need to do is save your data by going into your test run. We were test 120, and so we need to export raw data and then save it in a location that you want by looking at the file path. I think I normally put it on the we have a data folder, so you'll want to put it in the data folder. It'll automatically be in that file path. Remember your test run and then click export, and then always check your data right away to make sure that it actually saved everything properly. So we'll just open that up really fast. Test 120, and here's all of our data. So that was the full slotted test. You're going to run 2 tests. We did the slotted test, and then here's our closed thin wall. Both of the procedures are the same. The main difference is the actual software itself. You need to open up 400 inch-pounds in return for that. Thank you.